All right, well, thanks, Robin. Honored to be here. I always love being able to be present with the communities that are like the one I grew up in. My background was, as Robin said, I grew up on an organic farm. It was mostly a homestead. It wasn't an economically successful operation. My parents had a day job, which was running the local organic farming organization in Massachusetts and New England called NOFA. And so from a very young age, I was going to these kinds of conferences, and that's sort of the culture I grew up in. So to be able to be on stage with one of those other communities around the country is a great honor. I hope I hope I do the opportunity justice. I've been thinking about what it is that I want to talk about here today, and I thought probably a summation of my story would be a place to start with. And then there's two major things that I think I deal with. One is, as a farmer, what have I learned about how to work more well with nature? Because that seems to be, from a very practical standpoint, the best way to make a living, but also work to accomplish a number of other powerful things. And then the other thing that I'm getting to be more well known for in the past couple of years is the spectrometer, the bionutrient meter, and this topic of nutrient density. So my thought is I'll run in that order, background of myself, some of the insights from an agricultural, agronomic perspective that I think are relevant, that I did not grow up with, that I found to be very empowering. And then talk about the work with nutrient density and the vision and the opportunity and the strategy, and hopefully have time for Q&A as well. So if everybody's open to that strategy, I guess you don't really get much choice because I'm on stage and have the microphone. That's what I'm intending to do. So yeah, so I basically, as I said, I grew up on an organic farm. It was a homestead. My parents actually were community organizers in the inner city in Boston when they met. My mother grew up on a farm in Illinois, and she was pretty clear that we were all not going to grow up on the streets, but we were all going to grow up on the land. And so this was the late 70s when they started thinking about this, and we had the oil crisis going on. And so they basically designed a passive solar house with a root cellar and a wood stove, and built it on a field, on a dirt road, and we moved out to the country. And so that was I'd like to think I was more Amish than English. Anybody have Amish community around? You know what that means? We no TV, homemade clothes, homemade food. I certainly didn't fit in very well in the dominant paradigm going to school. I was quite an anomaly. I remember when I was in fourth grade telling my science teacher that I was a organic farmer, and she said, organic means contains carbon, you silly child, and all farmers are organic farmers. Of course, to ridicule amongst my peers. But in eighth grade, the LR scare had happened, and all of a sudden there was this click, and everybody knew that organic meant no chemicals. And then it was maybe 10th grade when the government came in and decided they owned the word organic. And in year 2000, they finally got around to establishing their standards, and we've seen what happened, with a movement that was grassroots and well-intentioned, that now allows hydroponic production and animals that never get access to the outdoors and things like that. So, I have that context, a lived experience, both as a farmer, but also having the organization running through my parents' house. They ran the annual conference. My mother was the executive director of the state chapter. My father was the editor of the journal for the 7 state chapter organization. So for whatever it's worth, it gives me a certain perspective. And the things that I may be saying about organic in a few minutes, remember that I grew up in the organic community. So I can say things because I'm an organic farmer. When I did, go through college and move on into my 20s, never really found a thing I wanted to do, a job. It was like, I'm going to be an engineer. I'm going to be a whatever. I'm like, nothing really ever appealed to me. I worked on the farm in the summer, and then traveled the world in the winter, doing all kinds of interesting things, which I probably don't have time for here. You're probably not interested in, or maybe you are, but not time for it now. But when I got married and had found no better lifestyle to raise children than the homesteading lifestyle that I was brought up in, I thought I would set about trying to be a farmer myself. And I think that's really when the story begins, was when I realized that I, like my parents, couldn't make a living farming. And that was primarily because my plants weren't healthy. We have enough rain where I come from. We also have plenty of pests and diseases. And for anybody who's struggled with said dynamics, it really does inhibit your yield, right? Pest pressure and disease pressure can be quite an issue. And so my thought was, if organic was supposed to be better, shouldn't my plants be healthy? And I'm pretty sure being eaten alive by a flesh-eating fungus is a sign of poor health. Powdery mildew, downy mildew, anybody ever heard of those things? Those are literally flesh-eating funguses. So if you think about it, the human context or an animal context, systemic staph infection, right? You probably wouldn't slaughter a chicken that has a systemic staph infection and feed it to your children or sell it. And yet we were annually picking cucumbers and picking squash that were attacked by powdery mildew and thinking nothing of it, eating them, selling them. Similarly with being eaten alive by larvae. If you had a cow that had, maggots laid into its back end and those maggots had hatched and they were eating the cow alive, you might think something was wrong with that cow, right? But our potato bugs were always eating our potato plants. Those are larvae eating the plants alive. That's a sign of poor health. You can talk about the tomato hornworm or the corn earworm. Those are signs of poor health. And those were inhibiting my yields. And that was a foundational insight for me, was my plants aren't healthy. Now, you don't see that happening in nature. You don't see the plants in the fields. You don't see the trees in the forest annually being, just eaten alive. So nature's doing something better than I'm doing. That was the basic point I started with. And I said, maybe organic is better because we're not using chemicals, but maybe there's more to it. And so that's when I started going to workshops, reading books, conferences, seminars, and it didn't take long at all, with some small modulations of change of practice, very limited economic cost, very limited effort and time, but looking at it from a different lens, to be at a point where pests were gone and diseases were gone, or at least they weren't attacking my crops. They were still attacking everybody else in the neighborhood, but they weren't eating my crops. And that meant that I was able to make a living much more readily. Going from working all the time and not having any money to working part-time and having plenty of money caused me to think that maybe there was something here. And growing up in this background and not having heard these things put together the way that I was starting to put them together, I felt like I needed to start talking about it. And so started giving workshops at conferences, and those turned into courses, and that turned into an organization. And starting in 2010, initiated the Bionutrient Food Association, which is the organization that I'm still the leader of. And our mission is to increase quality in the food supply. And by quality, we mean flavor, aroma, nutritive value, health-giving attribute, which we think correlates with plant health, soil health, farm viability, ecosystem function, human health, I would say cultural health, consciousness, all kinds of things. I grew up in a world where the nonprofit was the way we did things. And so I looked around and said, where is there a nonprofit, an educational organization freely sharing and coalescing around the concept of the actual quality of the food? Certainly the organic people like to think that they're producing superior quality food. The permaculturalists are pretty sure they're better. The biodynamic people know that their stuff is the best. All these different streams of thought sort of presume that what we're doing is producing better quality food, but from an active, specific standpoint, no one's actually assessing it. It's one of those things we just want to assume is the case, and as long as we all assume it, then we don't need to actually question it. But my thought was, if we have these things like pests and diseases and limited functionality, that may be a symptom of actually not optimal nutrition. And as I understand it, the purpose of raising food is to nourish. And so anyway, long story, but got into this work started giving workshops, courses. We set up a conference, established local chapters, tried to sort of coalesce around this topic of food quality and integrating the insight from the permaculture community and the insight from the biodynamic community and the insight from the organic community and the conventional community, IPM, universities, biochemistry, right? All these streams of thought all have relevant insight for one who wants to understand. It's not like one's better or one's worse or one's right, one's wrong. It's all context for the actual objective, which is that the food should be more nutritious. At least that's our sort of operating assumption. So I'd like to take a few minutes and just talk about some of those insights that I have come to as far as how to work more well with nature to get these results before talking about the stuff with nutrient density. So I'd like to say, to start on that topic of how do you work more well with nature, there's a few, I guess, if not dogmas, philosophical framework perspectives. One is, maybe people have heard of what would Jesus do? I say, what does nature do? What does nature do? How does she do it? That should be a foundational, alignment. I say, on which of the first 6 days did God invent fertilizer? Because it seems like if you look into the record, for about 300 million years, plants have been doing just fine without fertilizer, without insecticides and fungicides, organic or not organic, fertilizer, or organic or not organic, right? For a long time, plants have been doing just fine. If you look into the cultural record, if you look into indigenous communities globally, having managed landscapes to profound degree for millennia, and which continent do you want to look at to see how well it's been done, for how long, like with no plow, with no wheel, with no beast of burden, right? It's there. We have the perspective that shows us it can be done and done very well. We look at what they call agriculture with plows and with seeds, right? With wheat, and they talk about the Fertile Crescent in Mesopotamia. That form of agriculture, I think, has desertified about 40% of the Earth's land surface in the last 10,000 years. Right? We have all these examples globally of cultures that used what we call agriculture. They practiced agriculture and obviously failed, right? They engaged it for some time, they wore out the land, and then now that area is a desert. And we have other examples of communities here in North America, South America, Australia, where people were practicing a different form of agriculture, a much more integrated, maybe we can consider permaculture to be a very rudimentary version of what these cultures have done, and increased organic matter, increased biological vitality, facilitated symbiosis across the kingdoms. So just engage that perspective. What does nature do? How do you work in harmony with nature? Where do you see bare soil in nature? Not where she's doing well, right? So any ways in which we are managing the land to facilitate bare soil, one could argue, is a violation of nature. Where do you see monocultures in nature? Not very many places. So any way in which we're managing the landscape systemically to facilitate monocultures is probably a violation of nature. There's a lot of things that we do that we don't sort of question because it's received wisdom, because everyone around us does it, and that's just the way it is. But if we step back for a minute and look at the context, we can see that the net effect, the end game, the trajectory we're on is not particularly pretty. So anyway, those are sort of the rules of the road or some conceptual frameworks. How do you actually do it? How do you work well with nature? Because I grow monocultures, like my tomato patch and my cucumber patch, my potato patch. I engage in soil disturbance. I have an internal rule, which is I want to see my soil less than 2 weeks of the year, but whatever. I mean, I'm growing annuals, so we have to sort of find the middle ground and the balance here. Foundationally, I say most plants are green, and generally people agree with me. And we understand that plants are green because they have in their leaves this thing called chlorophyll, the chloroplast, in which occurs this process called photosynthesis. And people may probably mostly know the recipe for photosynthesis is carbon dioxide plus water, plus sunlight equals oxygen and sugar. And we generally know that the oxygen is emitted out of the leaves into the atmosphere and that we breathe it, as do most aerobes. And some of us know these days that most of the sugar in nature is injected out of the roots into the soil to feed the microbes. And so, we were brought up with this idea of survival of the fittest. And, if for me to win, you have to lose. Anybody heard of that one? The story, right? The colonizer's mentality. That's not how nature does it, right? Plants cover themselves in green to make oxygen, which they put into the atmosphere, and sugar, which they put into the soil. And that's been a successful strategy for hundreds of millions of years across the entire planet, across an entire kingdom. Maybe there's some wisdom there we can learn from. And so I say, why do plants do this? Again, because on none of the first 6 days did God invent fertilizer. Because plants, like animals, don't have the ability to digest their food. In nature, right, when we're born, there's 0 people between our mouth and our rear end. Right? The alimentary canal has no one in it. And colostrum, that thing which comes out of the mother's breast after birth, before milk, is there to establish our gut flora, because it's only the people inside of us that can digest our food for us. In fact, we have this flawed concept of being animals, right, or humans. There's all this identity conversation. I'm a he, I'm a she, I'm a brown, I'm a white, I'm a red, I'm a purple. Like, I say the first mistake is to think that you're an animal or a human, because 90% of the cells in your body are not, right? You know about this? The vast majority of the cells in your body are not human. The vast majority of the DNA in your body is not human. It's like 99% of the DNA, right? We are ecosystems. We are each an ecosystem, right? We have this reductionist mentality. The plants are here, the animals are there, the fungi are there, the bacteria are there. That's part of this reductionist, flawed paradigm. In actual fact, we are symbiotic ecosystems. And so as we need our gut flora, right? There's appropriating. As we need these symbiotes for us to function well, exactly so do the plants, right? The plants cannot function well without that symbiotic dynamic. It's foundational to their vitality. And so when I give a course, I like to say, it does not matter to me even one little bit, whether you're growing wheat or oats or apples or cucumbers or echinacea. It doesn't matter what the plant is. What matters is the microbial ecosystem. Are you managing the land in such a fashion that the bottom of the food chain will function well? That's your role, as I understand it, from the traditional indigenous community. The role of the human animal is caretaker, where our responsibility is caretaker of the land. And foundationally, if we understand how these things work, that means to manage the ecosystem such that the bottom of the food chain flourishes. Because when we do that, when we caretake the land such that the bottom of the food chain flourishes, then everything else takes care of itself. Right? I grew up on a farm where we worked all the time, and we didn't have any money, and we were stressed. I like being in nature. I love caring for the land, but I don't like being broke, and I don't like being stressed. I don't like working all the time. So my experience now is that when I manage the land in such a fashion that the bottom of the food chain is functioning well, I have time to take naps, to go swimming, to play with my kids, and now to go blow my mouth off around the world. But that doesn't mean that the foundation is creating that reality where the bottom of the food chain functions well. And so really I've condensed it down to 5 basic things that I say as a farmer, as a land steward, whatever your identity is there, to be managing for. Like, we're not trying to control all these little things. We're not trying to add this and test that and manage that. I'm just trying to make sure that these basic conditions are present. One of them, obviously, is air, because microbes, many of them, are aerobes, and they need air to breathe. So I say, I got a pretty good meter here. I take my hand and see how far down into the soil I can go. And if it gets really tight underneath my fingernails at 1.5 inches, I can fairly reasonably come to the conclusion that anybody who needs to breathe air that's 4 inches down is having a hard time it's probably dead. So if it's the microbes that are feeding the soil, that are feeding the plant, and they can't breathe because the soil's tight, then they're dead, and the plant's not getting fed. Does that make sense? So how do we manage the land in such a fashion as to maintain aeration? One of the things that I refer to when I'm giving a course is I start with this concept of what we do in New England in the fall is plant garlic. I mean, homesteaders do, they plant garlic. And so generally, I'll use the example of we're pulling out the fall carrots. I've got a quarter acre of carrots that I'm harvesting, and an eighth of an acre of garlic that I'm planting. We'll pull out the carrots by October 15th, and the next week we'll come in and make our beds and put the garlic in. Generally, when we plant the garlic, we put mulch down. And in the olden days, when I was a kid, it used to be that the ground would freeze, the snow would come, and the snow wouldn't leave until middle of March. The ground would stay frozen. Now, it doesn't work that way, but regardless, when this garlic starts to grow, we'll say end of March or so, if you were to pull the hay aside and reach down with your hand, first thing you might see is some earthworm castings, piles of earthworm castings. And the second thing you could do is you could reach down and you could pick up a handful of that soil. And if you wanted to give it a sniff, you'd smell that soil smell. But directly adjacent, right? Remember I said it was a quarter acre of carrots and an eighth of an acre of garlic. We mulched the garlic, but we didn't mulch the other part. Directly adjacent, what you'll find is tight, hard, cracked dirt, right? So you can try to reach down, you can't. You get a shovel in, you get a chunk out, you pick it up, it doesn't squish up very much. There's no aroma. One of those areas is aerobic. In one of those areas, the soil life can breathe and it's soil. In the other area, it's dirt, right? They're directly adjacent to each other, 2 feet apart. They both went through the same winter, freezing, thawing, snow, rain, not snow, rain, whatever it was, they both experienced the same climate dynamics. One of them is soil and one of them is dirt. And the reason why is because in one spot, the microbes had food, right? They need air to breathe, they also need food to eat. Where does nature have bare soil? During the growing season, when the leaves are green, they're making sugar, they're injecting it into the soil, they're feeding the soil life, great, all things are well and good. But in the wintertime, there's not green leaves growing. The microbes haven't taken off to go live in Florida for the winter. They're still home. Like, what are they eating? On the farm, when I grew up, we didn't buy much. Salt, grains, pepper. Like, there were a few things we purchased, but our meat, our dairy, our vegetables, our fruit was all homegrown. We put the potatoes in the root cellar, on the carrots and the beets and the rutabagas and the turnips. We had strings of garlic and onions. We had freezers full of meat and fruit. We canned tomatoes. We dehydrated. We pretty much ate off our land all year long, not because we were picking fresh off the land all year long, but because we stockpiled food for the wintertime. And that's what mulch is. That's what cover crops are, right? Keeping the soil covered is ensuring that the life in the soil has food to eat 12 months of the year. Because it's not about I'm producing crops from April to October. That's the only time it matters. It's about its life that lives there 12 months of the year. And if you're not managing the ecosystem so that they have food to eat for the entire year, you should expect them to starve to death. And then when they're dead, you've got dirt. And when you got dirt, you got problems. So you're really trying to manage proactively in such a fashion as to keep your soil from going to dirt. Water is another one of these key pieces of the puzzle. Obviously, people know about water. I like to say, whether you've got chickens or pigs or cows or children, just let them not drink for a week and tell me how they're doing. Apparently this is an issue, I've been told, in Montana, but from my personal experience, it's not an issue. This is a proper Appalachian rainstorm. You guys have been getting 2 days of slow, steady, sinking in rain. This is what it's supposed to be. This counts. But maintaining hydration is a foundational piece of the puzzle. And apparently that's a serious issue here. I totally appreciate the significance of it. We can look back into history and we can see how humans have successfully desertified the landscape. And we're certainly well into the process of doing that now, here and globally, not just, Nile River Valley and Mesopotamia and wherever. We're doing it globally. And so, as I understand it, maintaining the water cycle and maintaining hydration is one of those key pieces of the puzzle. There's all this conversation about carbon in the atmosphere, carbon in the soil, reducing our carbon emissions. As I understand the literature and the science and the opportunity, it's the water cycle that really is the one that we can turn things around with very quickly. So those who are not familiar with the information about the water cycle, I recommend looking into it. Walter Jenna is somebody from Australia who's had some really good pieces to offer. We've got a couple women from Vermont that have been doing good work. Didi Pershaus and what's her name? Oh, she wrote a couple books. Judy Schwartz. There's people all over the world that are talking about this more and more, but I use apparently it does rain here sometimes, and you've got lands where it ends up running off from. My understanding is strategically, we want to be having the land, the water captured before it runs off. We don't want it to be running off. We want it to be stockpiled in ponds. Beavers used to do a very helpful thing here, but getting the water table filled, slowing the runoff off the land, facilitates more things growing green. And that transpiration of water from green things growing, keeps the soil surface cool, but also makes clouds form, which makes more rain. So capturing the rain that you do have and ensuring it does not run off the land, at least with any kind of speed, I think is a very, very, very important piece of this broader puzzle. There's eco-restoration camps. There's the vision of the CCC from the 1930s when things were rough and people didn't have work and they were put to work outside doing things. I would say digging ponds and swales and stopping water from running off when it does come is one of the most powerful systemic things we can do for the ecosystem to passively support the cycles that do occur in regenerating as opposed to degenerating. And anyway, the broader point is, if you cannot maintain hydration, you should expect the microbes to shut down. And when the microbes shut down, the plants stop being fed. When the plants stop being fed, then they start to be susceptible to infestation and disease. We had a whole conversation about grasshoppers in the 2-day course we just did yesterday and the day before. Pest pressure. I'll just maybe do a quick little side note into pest and disease pressure. I think it's a relevant point. I like to say if there was a bale of hay in here, when any of you walked in, you might have considered sitting on it, but you likely would not have considered eating it. And yet, if someone had run a cow in, she probably would have considered eating it, but not sitting on it. And people say, yeah, that sounds, I'll grant you that point. And I say, then why is it that a cow can eat a bale of hay and you can't? And we know cows have 4 stomachs and they can digest complex cellulose and we can't. Okay, great. So we understand then that we have a different digestive tract than a cow does, and they can digest things that we can't. Everybody says, yeah, that's fine. Okay, great. So then understand that a Colorado potato beetle larvae has a different digestive tract than you do, right? You can digest things that it can't. It doesn't have a liver. It doesn't have the enzymes in its gut necessary to digest protein. So it seems to be the way it works is there's stuff that is good for us, that we have this inbuilt nutrient sensing meter evolved for, which is our nose and our tongue, which tells us when something's good for us is when it smells good and tastes good. Anybody had this experience of a tomato from the grocery store in February? Right? Or a peach off the shelf any time of the year, right? They call it a peach, but you damn well know it's not a peach because you've actually eaten peaches. Anybody ever had a peach off a tree when it was ripe? Right? That you as an animal know is a very pleasurable experience. You as an animal know that the peach off the shelf in the grocery store is not anywhere near as pleasurable of an experience. That's because you're wired with a nutrient sensing meter, which tells you what's good for you and what's not, right? Those compounds in the peach, which correlate with flavor and aroma, they're complex. They've got fancy scientific names. There's polyphenols and terpenoids and alkaloids and phenolics. There's all these fancy names for them. But those things don't get built in the plant until the fats and the oils get built. And the fats and the oils don't get built until the proteins get built. And the proteins don't get built until the carbohydrates get built. So there's this process of complexing of compounds, starting with simple compounds to greater and greater levels of complexity. And that process is actually a process of becoming indigestible for different types of what we call pathogens. Soil-borne pathogens, if anybody's ever heard of Rhizoctonia or Pythium or Alternaria, have a very, very rudimentary digestive tract from our perspective. They cannot digest a carbohydrate. So if your plants are building complex carbohydrates out of simple sugars, they become indigestible to Pythium, Verticillium, Alternaria. It's not a lack of fungicide, right, that is keeping them at bay. It's the fact that the plant is indigestible. Nature has evolved these processes. When your plant is able to build complete proteins out of amino acids, it becomes indigestible to larvae, period, larvae, right? This is how plants in nature do it. How they don't get eaten by larvae is they're indigestible to larvae. When your plant is building complete lipids, fats, and oils, it becomes indigestible to fungi. If you've heard of mildews, you've heard of blights, they're all fungi. When your plant has high levels of lipids in it, fats and oils, it is not digestible to them anymore. When your plant is building these, what's called secondary metabolites that correlate with flavor and aroma for us, animals, is when your plant is indigestible for beetles, adult insects. Grasshoppers fit in that category, right? Adult insects don't have as sophisticated of a nutrient digestion process capacity as we do. And so when something tastes good to us, it's that exact flavor, which is a thing that is unable to digest by those insects. So this is part of the understanding is when you maintain the environment where the plant has access to what it needs because it's got a healthy gut flora, it can build these compounds in its body and then it becomes indigestible. So I refer to these things, these insects and diseases, as nature's report card, nature's garbage crew. She's coming in with her people to take out the things that are unfit for reproduction. Nature's talking to you whether you want to listen to her or not. She's telling you this is unfit and this is. When you have animals eating your crops, then you're producing animal food. This was a really uncomfortable thing for me to come to terms with as a farmer, because from the 80s when we started our local farmers market in town, we always had our noses elevated because we were organic and they weren't. And we were out there with 5-gallon buckets knocking the Colorado potato beetles off the plants to keep the potatoes alive long enough to get something resembling a harvest. So if you told me that I was producing food that was fit for insects and not humans, I would have gotten very indignant. But humility is part of the process, right? Humility is part of the process of understanding. And so to the point about hydration, if your soil dries out and the microbes stop functioning, the plant stops being able to be fed well, and then it's unable to build these complex compounds, and then it becomes susceptible to infestation and disease. And that's just how it works. So we've talked about air, we've talked about food, we've talked about water. There's a couple more pieces here. One is minerals. There's this complex thing called biochemistry, which is really not that complex. But there's a whole bunch of different elements that are necessary for life to function. You may have heard the term enzyme. Anybody ever heard the term enzyme before? Not really know exactly what it means, but they're actually pretty simple. Anybody heard of bean and pea inoculant? Ever heard of that bean and pea inoculant? The Rhizobacter, Azotobacter, you put it on your alfalfa seed or your pea seed. Yes, I'm getting a couple nods, you know what I'm talking about, right? You buy this thing in a bag and you put it on your pea seed or your bean seed, alfalfa seed, and it's supposed to help those plants fix nitrogen because those plants are nitrogen fixers. So there's these two species of microbe they put in that bag, the spore form. There's Azotobacter and Rhizobacter. They also stick in that bag, which you may not have been told, this element called molybdenum. Molybdenum is one of the elements on the periodic table of elements, and it is at the center of what's called the nitrogenase enzyme. So the Azotobacter and Rhizobacter, those are the microbes, but they have a 9/16 or a 7/16 or a star bit, whatever you want to call it, a certain shaped thing called a nitrogenase enzyme that they grab the nitrogen gas out of the atmosphere with. Right? That's the tool they grab it with. It's called a nitrogenase enzyme, and it has one atom of molybdenum at its core. If you put the Azotobacter and Rhizobacter on the seed, but there's no molybdenum there, the microbes may be there, but the nitrogen fixation does not occur. You need the enzyme as well as the microbes, and so that's why they put I think over 1 million pounds of molybdenum into B&P inoculant in this country every year, because you need molybdenum for nitrogen fixation to occur. Minor point, you may not have heard about it, but still, if you look it up, it's true. What did I say about 300 million years? Plants have been doing this for a while. How many, of the grasses in this lawn here are legumes? How many of the trees in the forest out there are legumes? Who's adding nitrogen fertilizer to the forest? We all know that if you don't add nitrogen, things don't grow, right? But somehow, with no legumes, nitrogen is being cycled. And that's because, some plants have nodules on their roots where nitrogen fixers live, but other plants have nitrogen fixers that live on their stems and on their leaves, right? You don't have to have a nodule to have a symbiotic relationship with a nitrogen fixer. In fact, all plants for a very long time have evolved a symbiotic relationship with nitrogen fixers and can harvest all the nitrogen they need out of the atmosphere. There's a couple rules I've got on my farm. One is thou shalt not kill an insect. Second one is thou shalt not kill a disease. And the third one is thou shalt not add nitrogen, right? In nature, all plants have evolved the functional capacity to fix nitrogen from the atmosphere. So I want to hold my farm to that standard, right? As I understand it, added nitrogen is not what nature does in the form of compost or blood meal or whatever it is, urea, ammonia, liquid fish. That's not what nature does. Nature has a different pattern. So what I do on my farm is I make sure that there's enough molybdenum present, because molybdenum is an anion and it leaches out of the soil. And we know that the soils have been abused over time. So there are some minerals that are not present that life needs to function well. So you need 0.5 ppm of molybdenum per acre, which is 1 pound per acre, which is not really a hell of a lot, right? For all the nitrogen fixers on all the plants, all the kingdoms, all the families of plants, to be able to harvest all the nitrogen they need. If you don't have that molybdenum in the environment, because the soil's been poorly taken care of, because it's leached out, then that one thing, that limiting factor, is inhibiting this cycle from occurring. Another element I like to talk about is called cobalt. People who are vegans or vegetarians may have been told that they need to supplement their diet with vitamin B12 because they don't get enough in their plant-based diet. B12 is a compound that has at its core one atom of this element, cobalt. If you don't have enough B12 in your body, you become anemic, you become lethargic, you become very weak. If you really don't have enough B12 in your body, you become dead. We are B12 dependent organisms. At the center of B12 is cobalt. That means we're cobalt dependent organisms. We need it to exist. Guess what 80% of the species of soil life are? B12 dependent organisms. If you don't have cobalt in your soil, 80% of the species of soil life can't exist. So there's a critical, role for elements. We know about boron, we know about sulfur, we know about calcium, right? Silicon. There's all these different elements that are necessary for life to function. And in many cases, when you send your soil test off to your university lab, you get recommendations back for 3 elements. As I understand it, to replicate 1 strand of human DNA takes 25 different elements, not 5 potassiums and 6 coppers and 3 calciums, 25 different elements: cobalt, molybdenum, selenium, chromium, vanadium, yttrium, right? How many elements are you ensuring are present in your growing area? Because what you're actually producing is not pounds or bushels, but food. The objective is to produce food, and then therefore it must have those things which are necessary for you to function well. So air, food, water, minerals, and then life itself is the final piece of the puzzle. In many cases, the environmental conditions are such that you haven't, that species that are beneficial, that are symbiotic, that should be present are not present. And so this is where inoculation comes in. People may have heard about compost tea or indigenous microorganisms. There's Korean natural farming. There's all kinds of ways of addressing microbial deficiencies. But from a foundational standpoint, if you don't have that full spectrum of microbes present in your environment, you should not expect that full spectrum of vitality to occur. Anybody know about, I think it was St. Patrick killed all of the snakes in Ireland. Anybody heard that story? Yeah, so there's no snakes in Ireland, right? If there's no Azotobacter in Bozeman, you need a boy and a girl to make more Azotobacters, right? If you don't have certain species present in your ecosystem, then they're unable to reproduce and function. So this is where inoculation comes in. In many cases, inoculation is the least expensive, least time-consuming, least effortful, most powerful thing you can do. So anyway, these are sort of the broad spectrum of dynamics that I've learned about that, as a farmer, I try to maintain sufficient air, sufficient water, sufficient food, sufficient minerals, sufficient life. And in my experience is when those things are present, life takes care of itself. The plants grow themselves. I put them in the ground, I make sure the soil's covered, I make sure I can maintain hydration if I need to, and then I can take a nap, right? The amount of work necessary to produce crops goes way down. So that's the broad strokes of things I wanted to convey from an agronomic perspective. This is the sort of the basic content of the courses and the workshops that the BFA has been presenting over the past 10, 12 or more years. And certainly we did a 2-day course, or most of a 2-day course here in the last couple of days, and that's been recorded. And if you are interested, we have it also recorded other times, and it's all freely available on YouTube. So no need to take exquisite notes right now. If you're interested, just wanted to give you a taste of the concepts. What it is that I'm more well known for these days is the spectrometer and nutrient density by nutrient meter. So I'm not sure how much time do I have left, Robin?
You just said an hour.
Said an hour. Okay, let's figure that. Talked too long. All right, so nutrient density is going to be short. I presume we've got more farmers than consumers in this audience, so hopefully that was an appropriate balance of content. Nutrient density is this term that we helped to coin, or at least popularize, starting about 15 years ago. When I first got into this work, I was struck by the fact that it's like plant health, pest and disease resistance, nutrient levels all seem to be the same thing. And I was like, wow, who's talking about this? Where's the organization? And there was none. And I said, is there a word for this? And there wasn't one. So, in conversation with the elders in the community I was in, kind of consensus around this term nutrient density and started using it. And the basic concept is, as I said, with the tomatoes and the peaches, there's a variation in nutrient levels within a crop type. Some carrots taste good and some carrots don't. That's a nutrient density variation. There's a nutritional variation within those carrots. So as we started, spreading around the country and around the world with these courses, and we started talking about these ideas, and it looked like these principles applied across the board. It didn't matter your geography or your soil type or your climate zone or your crop type. Working with nature seems to work across the board. We said, if it's true that farm viability goes up, soil health goes up, ecosystem function goes up, nutrient levels go up, flavor goes up, human health goes up, if working with nature causes all these things to improve, wouldn't that be something that would be beneficial for us to do more of? And then the question was, how do we do more of it? How do we inspire the culture to focus on this? And so got to thinking and said, it seems like the world works these days to a large degree based on money. For better or worse, good or bad, money drives a lot of people's actions. So if we could align economic self-interest with ecological self-interest, with personal health self-interest, with nutrient levels, if we could align, economic self-interest with nutrient levels, we may be able to drive something much more broadly. And so the concept was give people who purchase food, who use money to purchase food, the ability to choose which food they purchase based on its nutritional value. So the concept is if there are 3 different bags of carrots that you can choose from off the grocery store shelf, you got a Bunny Love and a Cal Organic and a Bolthouse Farms, can give you something that you can take and you can flash a light at 20 out of 100, 40 out of 100, 80 out of 100. If we can give people the ability to discern directly, not trust a label or marketing or certification system, but actually choose directly what's available to them based on nutritional value, they will. right? We've got a really nice level of chronic disease coming along, right? Along with our levels of ecological distress coming along. It's starting to get visceral. It's starting to get really visceral for people. And so if we can say, hey, you go shopping, some stuff is not as good, some stuff is more good. We're going to help you choose the stuff that's more good. We think by having that stuff leave the shelf and the other stuff stay on the shelf, the system that exists will be inspired to focus on quality as opposed to volume. And so the idea basically was three things. One, we need to characterize the variation in nutrient levels because that has not been done. There's no data set anywhere which says this is what a high quality carrot looks like and what a low quality carrot looks like from a biochemical standpoint. It hasn't been done. So we have to do that. And then we have to build a meter that a person could use. There would be a consumer price point, handheld, non-invasive, and open source is our strategy so that it can't be corrupted or perverted or controlled later. If it's open source, it's in the commons, it can't be owned. So A, define variation, B, build a meter, and C, connect it to management practices. So because we're farmers, we want to basically facilitate a dynamic where farmers are empowered. And so we want to be able to connect this fertility program, this management practice, this cultivar, this microbiome, this epigenetic with this nutrient level. So we can support any grower who's out there in understanding how they can modulate their practices to get better results. So that was the grand vision. Define quality, get a meter to build it, to test it, and connect it to what the causal factors are. So in 2017, we built the first meter. In 2018, we built the first lab, started testing the first couple of crops. We had carrots and spinach. And if we were looking at elements like copper and zinc and iron, calcium, it was more like this carrot had as much calcium as those 3 carrots, so 3 to 1, 3x variation. If it was iron and spinach, maybe it was 18 to 1. This leaf of spinach had as much iron as those 18 leaves of spinach. When it was polyphenols and antioxidants, those sort of complex compounds, those flavor compounds, this carrot maybe had 75 times as many antioxidants as that carrot, or this leaf of spinach had 200 times as many polyphenols as that leaf of spinach. So minerals, it's 3 to 1, 5 to 1, 15 to 1, 20 to 1. That's the top to bottom variation we found in the supply chain. Like people just sent in stuff off the shelf, organic, not organic, grocery stores, farmers markets. When it's the higher order compounds, it's more like 75 to 1 or 200 to 1. That is the variation of nutrient levels in the supply chain. That was 2018. 2019, we added 4 more crops. We added a second lab at Chico State. And we asked the farmers to send in soil and report the management data. So we'd ask them, did you fertilize? If so, with what and when? What variety did you use? Did you till? If so, when? With what? How deeply? How many times? Did you use cover crops? If so, what? When did you plant it? How did you terminate them? Did you spray anything? Did you irrigate? If so, wet? Ask all these management questions and then ask people to send in the soil, top 4 inches, the next 4 inches, 2 layers, and the crop. So we can overlay the management data with the soil metrics, organic matter, mineral levels, biological activity, pH, with nutrient levels. That was 2019. 6 crops, 35 farms, and a bunch of stuff off groceries ourselves. 2020, we added another lab in Europe, in France, and we went up to about 25 crops. Oats and wheat, grains, roots, leaves, and fruits. Right, 25 crops, hundreds of farms, and got enough data at that point to say categorically, yes, these management practices correlate with these soil metrics, correlate with these nutrient levels. We also had enough data to calibrate our meter with. So in 2021, we released the second generation of our bionutrient meter, which is calibrated to 10 different crops. So you can now go to the grocery store, flash a light at zucchini, and see this is 80 out of 100 in the variation we found, or 20 out of 100. Wheat berries, we got a really good calibrations for wheat, for those that grow wheat. Carrots and lettuce. So I think I'm running out of time, but broadly, the idea is, right now, this meter we've got, I've got one right here. It's, I like to call it an Apple II, which everybody knows what an Apple II was. It was one of the first personal computers. It was quite rudimentary, not fancy. If you weren't a coder, you could barely use it, right? Maybe it came with Frogger, but Frogger is not a very sophisticated program. So that's where we're at right now. Our intention is that by next year, we have been able to mass produce these things. So engineered for mass production. These are basically produced, it's not a garage, but it's basically a garage, right? Like 3D printed, hand built one at a time. If we get 5 made in a week, we're doing good. There's hundreds of them out around the world, but only hundreds. And they take a long time with the smartphone it's Bluetooth too. You have to press the button a bunch of times to get a reading. It's not slick. It's not easy to use. It does work, but it's not easy to use. So our hope is by next year, we have 10,000 of these out around the world. And my concept is take Helena as a city that maybe has 10 different points of purchase where you can get food. If you've got 10 people in Helena that have a meter and they go shopping once a week and they each go to their different store and they spend an extra 20 minutes flashing lights at all the potatoes there's options for, and all the apples there's options for, and all the lettuce there's options for. One person assessing that grocery store or that farmer's market once a week, all that data goes uploaded into the cloud, and then anybody in Helena can see where the best blueberries are and go shopping there for the blueberries. And they can see where the best carrots are and go shopping there for the carrots. So if you can do this in 100 cities or 1,000 cities in 50 countries and 6 continents next year, we can begin to apply the economic leverage to inspire the supply chain to focus on quality as opposed to volume. So we're not done. This is a big, long project. I haven't told you about the beef project and everything else. I'm running out of time. But conceptually, the idea is to align self-interest, to keep it open, keep it in a place where it can be trusted and honorable, and support people in making good money doing the right thing. Right? I'm entirely in favor of people making money because that's the way the world works. I just want to make sure that this core nugget of what we're doing is kept in the commons. The data is in the commons. The engineering is in the commons. The software is in the commons. It's not owned or controlled by a company, so it can't get perverted in the way that this organic certification system was, in my experience. So I maybe have time for a couple questions?
Oh, yeah, you definitely have time.
Okay, I definitely have time. All right, I was here rushing, skipping stuff, but all right. Thank you all. Love to engage. Yes.
So you mentioned wheat and berries, but once something is processed, say in the flour, does it then lose its ability to get a reading?
So wheat berries, when something's processed, it loses the ability to get a reading. So what we've done so far, the way it works is when we get a sample of wheat into the lab, we first take the meter and flash a light at it to get a spectral signature, and then we run it through the lab to get the mineral levels and the compound levels off of that, the protein levels. And then when we've got, we've tested 300 samples of wheat, then we've got the spectral signatures and we got the numbers, and we can use algorithms and AI to say, this spectral signature means this, and this spectral signature means that. So we haven't done that with with flour, but we certainly could. It's just a process of calibrating the instrumentation to the thing. So this whole thing is a bunch of science, heady, obnoxious, expensive lab work. And we're not talking about Doritos, right? We're just talking about carrots and spinach and wheat and steak, the raw food. Right. And so if you can do it with the raw food, then you can do it with other things going down the road that are more market relevant. As I said, we're a nonprofit. Everything's open source in the commons, which means everything's being done on charitable donations, which means it's a pain in the butt to fund it. Right? I've had lots of people over the years say, here's $10 million or $50 million if you want to have a company and we can work together and sell all kinds of things. I said, no. It's important to me that this all stay in the commons. And if anybody owns it and controls it, then it can be in a point where it won't be trusted later, which basically means that we're limited by the amount of money we have, which is generally people who are well-meaning don't have good money, and people who aren't well-meaning, I'm going to say that quite that way, but people who have money generally want more of it, and they're not willing to just donate it for the general good. They'll say, if you can give me a 3x return on this research, I'll support you, or a 3x return on this meter, I'll support you. And I'm like, if we don't own it, it becomes difficult for us to give you a 3x return. And so we basically get stuck there. So yes, in principle, we can go forward step by step with everything in the supply chain. This is where we're at right now. You're getting me in a moment in time. We started at some point, we're here now, we're gonna be somewhere further along in a few years. But yeah.
Nitrogen is very important to the soil. You did a good job of explaining how it's important to add molybdenum to the soil because the nitrogen producing nodules in legume roots need molybdenum.
Yeah.
My question is, have you heard of any research that says that you can benefit grasses in plants that don't have nitrogen producing nodules? Will it help them?
That was my point, is that every single plant in nature has evolved the capacity to work with nitrogen fixers. So there was a Russian microbiologist called Krasilnikov who in the 1970s published a work that said every single crop plant globally, every single family of crop plants used by people in all continents has evolved symbiotic relationship with nitrogen fixers. They may not have nodules. That does not mean they do not have relationships with nitrogen fixers. Pine trees have relationships with nitrogen fixers. Corn plants have nitrogen fixers relationships. Broccoli, every single plant has evolved a symbiotic relationship with nitrogen fixers. Just because some plants have nodules doesn't mean you need nodules to fix nitrogen.
And they all need molybdenum.
You can use vanadium. So there's this thing called primary and secondary and tertiary enzyme pathways. So nature is so sophisticated that she doesn't ever just have one way of doing things. So molybdenum is the primary enzyme pathway, but vanadium is another element that can be used to make that nitrogen fixing function work. So there are other elements, many of which you probably haven't heard of. One of the things I emphasized at the end of the course yesterday is between rock dust, like basalt or granite or whatever, and sea salt, we have all of the elements we need to remineralize the land globally. So the continents are made out of rock, the oceans are made out of seawater. The reason you haven't heard about the amazing value of rock dust and seawater is because there's too much of them out there and nobody can corner the market on them. And you know, every time you market a product, you have to charge more for the marketing function. So if you understood that the quarry down the street that the gravel for the road was harvested from can be a powerful source of minerals for your land, and it costs $2 a ton to buy it, right? Then all of a sudden, there's a window of opportunity of what's possible. But who's going to educate you about the value of that quarry dust? Most of the things you learn are from people who have an economic interest in selling you something. This is a particular issue of mine as a farmer, that all the things we're taught to do come from people who have a vested interest in selling us something, right? Little trays, potting soil, fertilizer, tractors. Where do you want to start, right? Indigenous communities globally have shown us we need none of these things. Seed, right? It actually happens that seed falls on the ground and germinates when it wants to, when it's ready to, and oftentimes does better than the stuff that we plant or start inside and then transplant. But we're taught to buy things, and we have been taught from a very young age to take part in this capitalist system when actually nature has everything we need. But who's going to educate us about that? Who's got the economic incentive in educating us? That's why I set up a nonprofit, was because nonprofits aren't trying to make money off of you. Their objective is to educate. And I saw a big fat hole in this topic of organizations working to share this understanding. So yes, all plants have the capacity to work with nitrogen fixers, not just legumes. Yeah.
And speaking of education, Robin mentioned it really quickly. The interesting thing about your organization that's highly unique is you've talked about sort of one half of it, but the other half that you do in your educational programs is the human health side.
Yeah.
You bridge the people. So you said, so the last I saw, you were going to have your in-person conference together here in December. Can you just give us some insights into what you're going to cover or what you're trying to accomplish this year?
Yeah, well, I mean, I think the deeper topic is the human health topic. You know, I like to say we are at this really exciting time when things are falling apart all over the place. And I personally was having this conversation, I think, with John Brown, was it last night? About in the 60s, when my father was in his 20s, people were getting drafted to go to Vietnam, and there was like a visceral incentive in standing up and pushing back against the system. When I went to college in the 90s, we had just won the Cold War, and anybody who was looking for a job got one, and you didn't really have to be that intelligent or that capable, and all was well and good. Now, like, there's a suite of apparently existential crises occurring simultaneously, right? The climate, health, politics, economics. I mean, where do you want to look? Media. So I am excited because when I was in my 20s and I was like, guys, things are screwed up. Let's do something about it. There was nobody else who was like, things are screwed up. Like, hey, I can get a job, we get money, we get, Now we're on the edge. And so for me, the fact that, chronic disease is at epidemic levels is one of the most powerful vectors around which we don't have to organize. Because people care about themselves, they care about their children. Anybody got kids? Some of you have kids, some of you don't have kids, I'm guessing, right? If something's wrong with one of your kids, that kind of like takes precedence over other things. Anybody had a serious health crisis? Right? I know a lot of people in their 20s and 30s who have had extremely serious health crises, right? They're like on the edge of death and the doctors didn't help them. They were either gonna die or they had to figure out some way to heal their microbiome or whatever it was. And so the fact that so many people, either themselves or those they care about, are experiencing serious health issues, to me is a powerful opportunity because there's a visceral need for food that is healing. And so we don't have to go out there educating about it. We need to create a trusted framework that people can use to empower themselves. And that's where the meter comes in, is we can give people the ability to make choices for themselves based on what they do every day, which is buy food, that'll empower them. And oh, by the way, that also will heal the climate. And they don't really care about farmers, but if the farmers are using less fertilizer and their cost of production is lower and their overall system function is higher, then they're gonna make a better living. So I would say it's great if we have the consumers aware of the farmers, but I'm not convinced likely to care about the farmers necessarily. They're more likely to care about themselves and their kids. So if we have a system that automatically aligns the self-interest of all these different constituencies, which is the ability to choose food based on nutritional value, then we don't need to worry about all the education and the organizing and the broad-minded thinking. We can just stay with people's selfishness, right? So yeah, I think health is a really visceral piece of the puzzle. It's sort of implied. I'm sorry I didn't talk about it fully. Yeah. At time or past time. Thank you very much.